good morning to each one of you, dear students. Welcome to this digital chemistry class. As we have already started our unit 7, that is equilibrium. And this chapter is very important if we will take examination point of view. This chapter will come of 5 marks, and the chapter is divided into two parts as we have yesterday discussed: chemical equilibrium and ionic equilibrium. So in chemical equilibrium we are doing basically the chemical equilibrium. So let's start the introduction of chemical equilibrium. In introduction, it is given there a paragraph. Just we will start. When a liquid evaporates in a closed container, a molecule with relatively higher kinetic energy escape the liquid surface into the vapor phase and strike the liquid surface and are retained in the liquid phase. It gives rise to constant vapor pressure because of an equilibrium in which the number of molecules leaving the liquid equal to the number of returning to liquid from the vapor. We say that the system is in equilibrium state. So let me explain the situation. Suppose, dear student, this is a closed container where we have kept some liquid, let it be water, and when we are going to increase the little bit temperature, what will happen? This liquid will change into gas, and one stage will come when the at constant vapor pressure, the number of gaseous particle is equal to the number of liquid particle. It means that when these gas are reaching on the surface, it will start becoming drop again, condensation. So one stage will come when liquid and vapor state, it will remain same. At that stage it is called equilibrium state. That stage is called equilibrium state.
General characteristics of equilibria involving physical processes. At equilibrium, the measurable properties of the system becomes constant. At equilibrium, there is a dynamic balance between the two opposite processes. The equilibrium can only be attained in a closed system. When equilibrium is attained, there exists an expression involving the concentration of substances involved in equilibrium, which reaches a constant value at a given temperature. The magnitude of the constant value of the concentration indicates the extent to which the process proceeds before reaching equilibrium.
Okay. So the mixture of reactant and product is called equilibrium mixture. So if we will discuss some of the definition here, the mixture of reactant and product is called equilibrium mixture, and the stage where there is no change in the concentration of reactant and product is called dynamic equilibrium, and the equilibrium which involves ions are called ionic equilibrium. So generally we are discussing chemical equilibrium and ionic equilibrium in this chapter. So dynamic equilibrium is under chemical equilibrium and ionic equilibrium is second part of this chapter. So we will discuss one by one. So equilibrium in physical processes. So let's start the classification of equilibrium. Equilibrium is a state at which the concentration of reactant and product do not change with time. This is the definition that we studied. Or in other words, we will say it is the rate of forward reaction which become equal to the rate of backward reaction. So now the classification of equilibrium, the equilibrium that is set up in physical process is called physical classification, which is most famous example of physical equilibrium is phase transformation process. It means that solid change into liquid, then after solid change into liquid, when solid will change into liquid when we are going to increase the temperature. On the other hand side, the liquid will change into solid again when we are decreasing the temperature. Okay. So similar way, liquid will change into gas when increase the temperature, and gas will change into liquid when decrease in temperature. And solid will change into gas, gas will change into solid also by changing the decreasing. So solid to change into liquid is called melting, and liquid change into solid is called freezing. Liquid change into gas is called evaporation, and gas change into liquid is called condensation. These are the some basic terms that we need to understand. Besides these, there are some equilibrium involving dissolution of solid or gas in liquid. that is solid change into solution or gas change into solution. Basically, if solid liquid equilibrium will talk, so then it is simply that solid change into liquid or ice change into water, we can say. So before going to understand the next classification, let's understand the concept of equilibrium. In concept of equilibrium, we will understand with the help of this graph, dear students. So let's see. There is a graph between time versus rate. Time versus rate. Rate is time. Rate is speed of reaction. Okay. As the time will increase, you know that first the reaction is in zero. Reactant is at zero speed. It is not like when we are going to start a car, though when car is on the parking, so that time the speed is zero and time is also zero. So as the speed will increase, the time will decrease, you know very well. Okay, as we move, start accelerating the car, the speed will increasing, and with the increase in speed the time will decrease. Okay, so same thing is happening with the reaction. When the product Kr mean rate constant at reactant, nitrogen dioxide square is in the reactant side. Here slowly it will its speed will increase with the time. Okay, so one stage will come when its forward reaction becoming product is becoming equilibrium to the backward reaction. At that position it is called equilibrium stage. When rate of forward reaction, both the forward and reverse reaction are occurring, at that point where forward and backward reaction are occurring is called equilibrium. At equilibrium, the forward and reverse reaction are proceeding at the same rate. Okay, so this is the basic and a system of equilibrium we need to understand. So what is happening? Once equilibrium is achieved, suppose this is the stage where equilibrium achieved, the amount of each reactant and product remain always constant. Then whether you increase the concentration of reactant, it will not going to change the rate of reaction. Here NO2 plus N2O4 has reached to equilibrium stage. Okay, after that it will you can see here it is not going to change, it will remain constant. Up to here it is changing. You can see once again NO2 is increasing toward product and N2O4 is decreasing toward reactant. But one stage will come when after that it will remain constant, it is not going to be changed. That stage is called equilibrium stage. And depicting equilibrium, in a system of equilibrium both the forward and reverse reaction are being carried out as a result. So if suppose we are telling N2O4 will give 2NO2, so it means that rate of forward reaction is equal to rate of backward reaction. It's stage where this rate of forward reaction is equal to rate of backward reaction, that is called equilibrium. So in equilibrium the time is very important. The time factor is very important. As you know, there is time, when time is 0. So what is happening? The solution of N2O4, this is N2O4, will going to be changed into N2O4 when after 5 minutes or 10 minutes you can see some more N2O4 will change into NO2. Then after 20 minutes more NO2 is there, and after 40 minutes again it will remain same. Then there is no chance to increase more NO2 because it will remain always same. So this situation is called equilibrium state. After that it is constant, it is not going to increase. So equilibrium involving dissolution of solid and gas in liquid. Equilibrium also involve dissolution means solution को नहीं बनने देना solid और gas में. In solid in liquid we will take when no more solute can be dissolved in the solution is called saturated solution. That's you know. So in case of sugar is a when sugar is in solution form and sugar is in solid form. So if more and more sugar we will add in solution, then it will not allow, this solution will not allow more sugar to dissolve. That situation is called saturation solution, and that time the rate of dissolution of sugar is equal to the rate of crystallization of sugar. At that time the solution which we are adding in sugar, it will going to change into crystallization. So the ratio of radioactive molecule to the non-radioactive molecule in the solution increases till it remains. Gases in liquid, we are going to study under Henry's law. So what is Henry's law? He told the solubility is directly proportional to molar concentration. It means the more the solubility, more the molar concentration. There is a certain equilibrium between the molecule of the gas state and molecule of the liquid state. For example, carbon dioxide gas, when going to dissolve in a liquid, it will become carbon dioxide solution. So Henry's law states that the mass of a gas dissolved in a given mass of a solvent at any temperature is proportional to the pressure of the gas above the solvent. It means that you can take it like this way: pressure is directly proportional to solubility also. Okay, so the amount of decrease with the increase in temperature. For solid and liquid equilibrium, there is only one temperature, that is at 1 atmosphere, at which the two phases can coexist. If there is no exchange of heat with the surrounding, the mass of the two phases remain constant. For liquid and vapor equilibrium also, if pressure is the constant at given temperature. For dissolution of the solid in liquid, the solubility of constant at given temperature. And the same way, for dissolution of gas in liquid, the concentration of gas in liquid is proportional to. So it means that in case of dissolution of gas, the concentration of gas is important. For dissolution of solid in liquid, solubility of constant is important. Liquid vapor pressure is important. And in solid and liquid, the temperature is important. Okay. So general characteristics of equilibrium involving physical processes. The general characteristics of equilibrium, when we are going to talk about the physical processes in physical equilibrium. Equilibrium is only possible only in a closed system at a given temperature, because there is no effect of surrounding. Okay, surrounding का कोई effect नहीं है. तो equilibrium is only possible only in a closed container. Both the opposite processes occur at the same rate. When both the opposite processes like forward reaction is equal to backward reaction, it will remain same, and there is a dynamic but a stable condition. When equilibrium is attained for physical process, it is characterized by constant value of one of its parameter at given temperature. The magnitude of such quantities at any stage indicates the extent to which the physical process has proceeded before reaching equilibrium. So it is these are the two basic characteristics. You just pause the video and note down these two. Dynamic equilibrium, if I'll tell, the dynamic equilibrium is somewhere known as chemical equilibrium also. Chemical equilibrium is the stage at equilibrium where chemical reaction occur. Okay, suppose generally case of the dynamic equilibrium reaction is, for example, A and B, A plus B will react into and give C plus D. A plus B is reactant, C plus D is product. With the passage of time, what will happen? There is accumulation of A and B. Suppose A bond B is there and it is forming somewhere C and D. So what is happening now? Slowly A and B's bond will break, and B between D bond will form, C and D bond will break, and between A and C will form. So in that situation, what is happening? The product C and D, which is depleting the reactant A and B, this lead to the decrease in the rate of forward reaction. Yes, it will decrease rate of forward reaction and increase the rate of backward reaction. Finally, the two reactions occur at the same rate, and the system is called state of dynamic equilibrium.
Equilibrium in chemical processes. Dynamic equilibrium. The reactions in which products do not react to form reactants back are called irreversible reactions. For example, silver nitrate reacts with sodium chloride, gives rise to silver chloride and sodium nitrate. The reactions in which products react to form the reactants back are called reversible reactions. The reversible reactions are represented by putting two arrows pointing in opposite direction. For example, hydrogen reacts with iodine, gives rise to hydrogen iodide, the state at which there is no further change in concentration of reactants, and product is called chemical equilibrium. At equilibrium, the rate of forward reaction is equal to rate of backward reaction. Chemical equilibrium is also dynamic in nature because reaction does not stop at equilibrium. The rates of forward and backward reaction being equal, the concentration of reactants and products remains constant. Let us illustrate the state of equilibrium with the help of example. Calcium carbonate, when heated to 1073 Kelvin in a closed evacuated vessel, starts decomposing to yield calcium oxide and carbon dioxide gas. Carbon dioxide builds a pressure. The pressure goes on increasing as the reaction proceeds and finally becomes constant and remains so as long as the temperature remains constant. It appears as if the reaction has come to a stop, although calcium carbonate is still present. This indicates that this system has attained the equilibrium.
Students, before going to move law of chemical equilibrium, which is equilibrium constant, it is very important. Let me tell you about the characteristics of chemical equilibrium. So please note down. First characteristic is at equilibrium the concentration of each of the reactant product become constant. Number 2, the equilibrium is dynamic in nature. Number 3, a chemical equilibrium can be established only if none of the product is allowed to escape out. Number 4, chemical equilibrium can be attained from either direction, that it from the direction of the reactant as well as from the direction of product side. A catalyst doesn't alter the state of equilibrium. And last characteristic, at equilibrium the Gibbs free energy is always 0. Okay. So the law of chemical equilibrium, if we will talk, the law of chemical equilibrium is very important, which is also known as law of mass action. So according to law of mass action, the rate at which the substance react is proportional to its active mass, and hence the rate of chemical reaction is proportional to the product of active masses of the reactant. The law, when we are going to discuss about the law of chemical equilibrium, so we will discuss it with the help of one reaction. Let it be A plus B will change into C plus D, and this is a reversible reaction. So law of chemical equilibrium will be always applicable for reversible reaction only. It is not applicable for non-reversible reaction. Okay. So these reactant and product are balanced. If these are balanced, then only it is known as equilibrium. Hence we can relate them in an equilibrium equation like this way. Kc is equal to molar concentration C and D upon molar concentration of A and B, where Kc is called equilibrium constant and the expression on the right hand side is called equilibrium constant expression. So it means that Kc will be written, if suppose I am taking one example of any example, if I will take example of suppose H2 plus O2 again will give 2H2O in the presence of 2. So what will be the Kc? Kc will be the H2O square, because this 2 will go in square, upon H2 again square O2. So we will write the equilibrium constant like this way. So this is the equation that will change this reaction into this. So question is coming sometime, write the chemical equilibrium stage for this particular example. So at that time you should know how to write. Okay. So this is at given temperature and product of concentration of the reaction. This is the definition of law of chemical equilibrium. So note down. At given temperature, the product of concentration of the reaction product raised to the respective stoichiometric coefficient in the balanced chemical equation, which is divided by the product of concentration of the reactant raised by their individual stoichiometric coefficient, hence a constant value. This is known as the law of chemical equilibrium. So what is the Kc? Kc is equal to product of the C and D is product of the, what is written C here, it is the product of the concentration of the reaction product. It is the product of the concentration. This bracket is called concentration. This is concentration product raised to the respective stoichiometry. If any value is there, that is need to be raised down. Let me make it with different color. So what is the product? If I will say Kc is equal to CD upon AB. Okay, if reaction is A plus B, which give us C plus D. So the reactant language is coming at given temperature, the product of the concentration. The product, this is the product of the concentration of the reactant. Reaction product raised, if there is some coefficient like 2C, 2D, so that we will write in power stoichiometric coefficient, which is called stoichiometric coefficient. In the balanced chemical equation, divided, this is divided by the product of the molar concentration of reactant with the raised to power of its coefficient, stoichiometric coefficient. Okay, if suppose here also some. So this is the law of chemical equilibrium. Equilibrium constant for a general reaction can be written like this way: A, B, B, C, C plus D, D. It means that now A is what? Kc can be written now C, molar concentration C, D small d, A small a, and B small b, because A and B is the coefficient. So what does the value of K now? The value of K mean when reactant is going to change into product. When reactant is changed into product, it is there the forward reaction of reactant is equal to the backward reaction also. Okay, but when K value is more than greater than 1, the reaction product favored and product will form. If it is a reverse, it takes place then the former predominator. It means that then K value of K is smaller. When K value is greater than 1, the reaction is product favored. It means the product will form. And when K is smaller than 1, the reactant is reactant favored. It means that reaction will be reversible. It means that in case of reversible, K's value is smaller than 1. In case of forward, K's value is greater than 1. Okay, so dear student, this is all about the value of K. Now tomorrow we are going to study about the law of chemical equilibrium. So till then, take care, stay home, stay safe. Hope so you enjoyed this video. Try to understand the equilibrium concept. Read it from your book. We have done today physical equilibrium and chemical equilibrium. Now tomorrow we will do law of chemical equilibrium and equilibrium constant. Okay, so thank you, thanks a lot. Have